Hello. Today we're going to talk about graphing parabolas. The first thing you know about graphing parabolas is that parabolas are the graph of a quadratic function. So a quadratic function is f of x equals ax squared plus bx plus c. And if you want, instead of f of x, you could put y equals, it's also fine. The basic shape of a parabola is, people call it U-shaped. It's not really a U, but it looks something like this, or something like this. A parabola can open up or down, left or right, or any other direction you want. For simplicity, for college algebra class, or any algebra class really, is we're going to stick with up and down. Now, there are two forms of a quadratic function. The first one we just mentioned is f of x equals ax squared plus bx plus c. The second one, f of x equals ax minus h squared plus k. Sometimes it's referred to as vertex form. The thing I want you to know here, you can write any quadratic function in either of these two forms. So either the first form or the second form. The only value that will be shared that means anything is the a here and here, if it's the same parabola, will always be exactly the same. The h and k and the b and c could possibly line up as the same values, but even if they do, it means nothing to us. So there's no association there. So let's be careful on that. Now the A tells us a lot about what to expect from the parabola. So if A is greater than 0, then the parabola opens up. If A is less than 0, then the parabola opens down. The A will also tell us how thin or wide a parabola we can have. To look at that, you need to note that the absolute value of A. So the absolute value of A is close to 0. So basically, smaller than 1, then the parabola is wider. Because the absolute value is further from 0. Usually, that means bigger than 1. parabola is narrower. All right. Now, every parabola has one unique point. It's the only point that doesn't share the same y value, right? If you look right here, this point right here, this point right here have the exact same height. These points here and here have the exact same height. The only point that doesn't share that point is this, the lowest point here, the highest point. And this point here is called the vertex. How you find the vertex depends on what form you're in. So I'm going to note here. Depends on the form of the quadratic equation. So you're either going to have y equals ax squared plus bx plus c, or y equals a x minus h squared plus k. And we'll address both these individually. So this video here is actually going to address this form. I'll make another video to address the other form. Before I do a couple examples, I want to mention domain and range. The domain of a parabola. Here's the thing. The arrow up here and here is pointing up and right, which means it's going to the right forever, and it's going up forever. The one on the left points up and left, so it's going up forever as it goes to the left forever. Again, here's this one, these two here, down forever and left forever, right forever and down forever. So both of them go to the left forever and to the right forever, which means I'm covering all x values, all the horizontal area. So the domain of a parabola for us is positive infinity to minus infinity. The range is slightly different. Again, just a quick reminder. Domain, x values, and range is y values. Well, if you look at our pictures right here, right? We either start at wherever this y value is right here, and you go up to infinity, or you start at the y value here, and you go down to minus infinity. So your range is going to be either the y value of the vertex to infinity, and this is interval rotation, or it's going to be minus infinity to the y value of the vertex. And again, this situation here, the y value to infinity is an open up situation. This one here is an open down. Okay. So finding the vertex of a parabola in y equals ax minus h squared plus k form. Well, it's called the vertex form a lot of times because it's very simple. All you do is you take h and take k. Now h, whenever you take it out, you take the opposite value. So it's going to be plus h and a k. So what it means is you take the opposite of this one and keep this the same sign. And that's our vertex. So if you invert this vertex form, it's very simple to get the vertex, not a lot of work. All right. Example. Let's graph g of x equals x plus 1 squared minus 2. It's my vertex, right? Take the opposite sign, same sign. So minus 1, minus 2. We got our vertex. Now let's look at A. If you come back, right? A is this number right here in front of parentheses. So in our case, A is 1. And scroll up real quick. We said, right, if A is greater than 0, we open up. So this mean is greater than 0. So we're going to open up. The absolute value of A equals 1. And so this is a weird case, right? Which has absolute values. If you're closer to 0, it's closer to 0, smaller than 1, you're wider. Further from 0, usually bigger than 1, is going to be narrower. So here we are exactly 1. So if I was to make a call on it, I'm going to call it greater. We'll call it, sorry. Actually, I'd probably call it no change. But that I mean no change from the original y equals x squared parabola. So that's what I would call it. Okay. Now, once we have all this, we need to graph it. I know it opens up. And I know it's very similar to y equals x squared in terms of shape. But we need more points. So the simplest way for me is just to make a table. Now, the vertex, right, when you open up, the vertex is right here at the bottom. So it means everything comes up from the left to the bottom. So I'm always going to put my picture at the bottom or the middle, right? So this is the middle of the picture. So my table, I'm going to put minus 1, minus 2. That's my vertex. Now I'm going to choose points on either side. I'm not going to go crazy, so things like 0 plus 1 minus 2 minus 3. I'll avoid using fractions as much as possible if I can. And that doesn't come up too much in an algebra class at our level. So now I find the y value. Right? Y values just mean I'm going to take g of x, and it's going to come down right here, and that's going to give me my y values. So I have 1 plus 1 squared minus 2. 2 squared minus 2. 4 minus 2 equals 2. That's my first point. Then I have 0 plus 1 squared minus 2 equals 1 squared minus 2. 1 minus 2 is minus 1. Minus 2 plus 1 squared minus 2. Minus 1 squared minus 2. 1 minus 2 minus 1. Finally, minus 3 plus 1 squared minus 2. Minus 2 squared minus 2 equals 4 minus 2. There we have it. That's our table. All right. Now, figure out drawing a picture. All right. So, I have the point. We'll start at the top point here and work down. So I point 1, positive 2. So 1, positive 2, right there. 0 minus 1, it's right here. Minus 1, 2 puts me right here. Minus 2, minus 1 is right here. Finally, 3, positive 2 puts you right here, looks like. And we'll do our best to draw a nice curvy, bowing out parabola. What I'd be checking for this is because when you freehand pictures, you don't always do great pictures. So I'd be checking for would be, is the table correct? Right? Is this correct? Once the table is correct, are the points put in the right spot? And then if your parabola still looks kind of funky, but all the points in the right spot and everything's correct, I give you full credit. All right, so the one other thing I'll mention is parabolas are symmetric. And we have what's called an axis of symmetry. And the axis of symmetry is a line, this vertical line, that equals, the equation for it is x equals, in this case, minus 1. It's the x coordinate of your vertex. And what it means is, if you look at this, if I go the same distance over here to the left and the same distance to the right, the y values should also be the same. So if you look at this, the distance between 0 and minus 1, they covered 1 unit, right? Distance here is 1 unit. And because those are 1 units, their y values are the same, because I fold over, like we have this picture over here, if I fold over my axis of symmetry, the y values will be the same. And here, again, right, if you come from minus 1 to 1, distance of 2, and minus 1 to 3, distance of 2. So the distance from the horizontal distance to left and right distance is the same. The y value has to have the same height. And so what we can do is we can use that. Instead of doing all these calculations right here, we can only do half the calculations and copy it down as long as we make sure our distance from the vertex on the left and right side is the same. All right, so let's try another example. We'll use symmetry to make life a little simpler. All right, here we go. So f of x equals minus 2, x minus 2 plus 4. And remember, put it down here. This is opposite. This is same. So the opposite of minus 2 is plus 2. The same as 4 is 4. There we go. Then A is minus 2, which is less than 0. You recall, less than 0 means you open down. So we're going like this time. The absolute value of A is 2. Let's scroll up and look at that again, just to make sure. The farther from 0, usually bigger than 1, the parabola is narrower. So this is going to be more narrow because it's bigger than 1. All right, now we're going to make a table. We're going to use symmetry. So 1, 0, 3, 4. And actually, let me change the colors here. 1 and 0 are the same distance from, 1 and 3 are the same distance from the vertex, so they share the same y value. And 0 and 4, 0 and 4 are the same distance, so they share the same y value. All right, so again, the y value is based off of f of x. We're just going to plug it into this. So we have minus 2 times 0 minus 2 squared plus 4. Minus 2 is minus 2 squared plus 4. So minus 2 squared is positive 4 plus 4. So minus 8 plus 4 is minus 4. So this is minus 4, and this is minus 4. Half the work right there. It's beautiful. Minus 2, let's do 1 minus 2 is squared plus 4. Minus 2 minus 1 squared plus 4 equals minus 2 times 1 minus 1 minus 1 is positive 1 plus 4 So you have minus 2 plus 4, 2. Now remember, the vertex is either your highest spot or your lowest spot, right? So take a look at this. We're opening down, right? Since we're opening down, that means it's the highest spot. So the vertex is at the highest y value, and all the other y values should get smaller as you move down. Is that happening there? Looks like it, so we're probably in good shape. Let's draw our picture, and we'll be done. Okay, I'm just going to start at the top for simplicity, since you can't see what I'm doing. We'll do 0 minus 4, which is right there, plus 1, 2, 2, 4, it's our maximum right there, and then 3, 2, and x4, y is minus 4. There we go. There we go, roughly. And you'll note, this parabola looks much thinner than our last parabola. And that's because of the a equals 2 right here. All right. Let me know if you have any questions.